Here's the science critic, and I'm going to put him on for a second so that you can hear what he has to say. And he's going to say that another existing thing that we have out there, he says that virtual particles exist. He believes that there are such things as virtual particles.
Wait, gravity doesn't exist either.
Exactly, because it's a concept.
This is getting weird.
Yeah, you can say that the ropes exist that cause gravity, but not the gravity. Or density. Density doesn't exist.
I don't want to cut you off. It just seems weird that all these concepts don't
exist. We got rid of all the concepts.
But that's also why you harp so much on not using the word density, mass, and all these things, because they don't really exist. Those are concepts in the sense that there's no shape there. There's no thing that's bumping into another thing.
They're placeholders. They're placeholders that people don't realize are placeholders. They put them in there and say, "Oh, the Force did that." What do you mean the Force did it? You mean the horse? The horse could have done it, not the Force.
Where's Yoda when you need him?
Okay, so this is this is our science critic, and he's going to say that virtual particles exist. And so the question to you, for you to think in the next few minutes, is: do virtual particles exist? If you know what they are. Otherwise, we're going to enlighten you on what they are. So here we go. Give me a second so I put this fellow on. The questions and issues to be addressed in this rebuttal include: are there such things as virtual particles? Do virtual particles exist?
Now it sounds like what he's talking about here are virtual particles, and virtual particles certainly explain certain things like the Casimir effect. Just because you cannot imagine virtual particles doesn't mean that they do not exist. Now it may be that virtual particles don't actually exist and there is some other explanation for the Casimir effect. But you need to actually come up with another explanation for the Casimir effect. Saying I can't imagine virtual particles doesn't cut it.
Okay, so the million-dollar question today is: do virtual particles exist? And for those of you who don't know what a virtual particle is, let's find the definition. Okay, so here we have the definition. We find out there: virtual particle exhibits some of the characteristics of an ordinary particle, okay, while having its existence limited by the uncertainty principle. Its existence limited. They're limiting the existence of God. Can you believe this? Okay, any object that exists for a limited time. That's what a virtual particle is. It's limited time, okay? And then virtual particles exist only temporarily. You know, sounds quite ad hoc to me if you ask me, right? The lifetime of real particles is typically vastly longer than the lifetime of the virtual particles. No kidding. If it's got limited existence, yeah. And then they finish saying the concept of virtual particles. What? Was a particle a thing, an object, or is it a concept? What do you mean a concept of virtual particles?
Well, it's a thing when they need it to be.
Yeah. So
what do they use virtual particles for? Just one example.
I'll give you an example. I'll give you a couple of examples. First, let me give you the example of the dark matter. And the reason I need to put that in there is that, again, is there such a thing as dark matter? Is there a physical object called dark matter out there?
I ain't seen no dark matter in my backyard.
It's not so much that, first, they can't see it or touch it, so that would, under the mathematical definition, see, touch, that would be excluded anyways. But how did they come up with dark matter? Why is it that all mathematicians believe in dark matter? Why all the astronomers pointing their telescopes out there trying to find it?
Looking for an invisible thing.
Where did they get this idea? Well, the idea came because there was an equation, and they needed to figure out why the stars on the outside, on the outskirts of the galaxy, were traveling faster than those around the galaxy, faster than those on the inside. And so they said the only thing they could come up with, the only explanation, was mass. They said, well, we only have one solution, that's mass. What else could it be? And so they started putting mass. They said, well, we're putting it by finger, we're putting it by hand in there. We're putting all this mass, sprinkling it on the outside of the galaxy just to make the equation come out right. And they called that ad hoc, putting of kilograms out there. They call that dark matter. So it was put in by hand. And the same thing comes with the virtual particle. They have an equation. And suddenly they accelerate a particle along the beamline over there at CERN or SLAC or Fermilab.
And it doesn't do what they calculated.
Well, they said, there's something else going on. I need some more charge. I need some more mass. I need some more energy. I need more something in there to fill in the blank, because otherwise the equation doesn't come out right. And so they said, well, why don't we borrow some energy, some charge, some mass, some whatever from this thing and put it in the equation? They say, hey, now the equation works. No kidding. And they say, yeah, but then suddenly the equation, it's like, it suddenly goes away. It's only a fleeting moment where they can measure that, and then it goes away. And so they said, well, we got a solution. We'll call it a virtual particle. It comes in when we need it, ad hoc, and then when we don't need it, it goes back to, I don't know, to Never Never Land.
They sound like bad mathematicians. Like they got the calculation wrong, and then they're like, oh, well, whatever we got wrong, let's just add
If anything, you could say it reverse. You could say they're good mathematicians, lousy physicists, because they haven't explained how this really works. And that explains why Mr. Feynman says no one understands any of this.
But it seems like their calculations are off too.
Well, their calculations are off, but they fix them immediately. They just put a
a
variable in there by hand, and they say, well, there it is. That's the solution. We put more charge, more energy, and in the case of dark matter, they put more mass, and they fix the problem. And now they tell the astronomers, go look for it.
I love that. What moved the curtain? God. Now go look for them.
Yeah, the angels.
Yeah, the angels. Point your telescopes.
Okay, so here's my analysis, okay, of virtual particles. Just a quick rundown. Virtual particle is not a particle. That's the issue. In QM, a particle is not a particle. Okay, people think of particle as some kind of corpuscle, a grain of dust, a grain of sand. You think of a little tiny speck of dust of some kind. That's what you're thinking of. That's what the layman thinks every time he hears the word particle. That's not what a particle is in quantum mechanics, let alone a virtual particle. Okay, so what is a particle? Well, there's three kinds, you could say, and they're all related to sizes. One is the macro particle, the one we all understand by the word particle, which is a speck of dust, grain of sand, any of those, right? That's a particle, something you can see, touch, macro. We'll call it a macro particle because you can see or touch it. You can relate to it. Then you have the point particle.
Here we go.
And this is a little tricky, okay? It has no size. It's a concept because it has no size. There's no volume, no shape, no nothing there, and they call that a particle, a point particle, right? That's a point particle, and it could be a gluon. They call it a point particle. It could be an electron. They call it a point particle. They've never seen one. They never photographed one. They never interviewed one, so they don't know what it looks like. They have no idea, and they don't care what it looks like. They just give it values. They say so much charge, so much mass. They give it all these mathematical values, these properties, but they don't tell you what it looks like. And they say we don't know what it looks like because we've never seen one. Period. We're done. And they call it a point particle. Okay. And part of that has to do with the fact that the point particle, they say it's an elementary particle, like you see it there at the bottom, meaning it's not made of anything smaller. It's like the ultimate particle. It's not made of anything itself, at least for now, until they smash it. And for that, they would need a collider as big as the solar system. So good luck with that one. And then you have the virtual particle, which is an ad hoc particle, which ain't a particle to begin with. A particle is not a particle, but here we have a virtual non-particle. Okay? And it appears at the whim of the mathematician to make the equation come out right. So you have all these different kinds of particles. You should be aware that when they're using the word particle in quantum mechanics, they're not talking about that first one, the macro particle, a real thing. They're talking about maybe a vibration, local vibration of a field. Maybe they're talking about wave-particle duality. The corkscrew, that Mr. Roger Penrose put in his book, Ridiculous Thing, where he shows this corkscrew that's supposed to represent both notions, the wave and the particle.
I mean, it's pretty close.
Corkscrew? That's about as good as it gets. Anyways, the point is, this fellow believes in little ghosts, in spirits. He thinks that there are such things as virtual particles because with it, they can explain the Casimir effect. Well, we don't need the virtual particle for that. We always had spirits for that. Angels, a God. We already had all those things. But
now you're just being facetious.
No, I'm not. I'm being realistic because traditional religions probably had a better answer than the virtual particle, which is a non-entity to begin with. I mean, if you bring an angel, I can imagine an angel. He's got wings, a little plate on his head. I can say, well, he did this. Well, yeah, okay. We can understand.
I thought it was a ring, not a plate.
Some people have a plate. Some have a ring. Yeah. I mean, I don't know. But angels, we can all imagine. But we cannot imagine a virtual particle because it has no size, no shape. It's just a value that they put in an equation whenever they need it, and it flies away whenever they don't need it. So what is that? It's just ad hoc. It's nonsense. Okay. So yeah, if I were to choose, I'll still stick to traditional religion and say that angels explain it better than virtual particles.